Let's see that my slides already working. Yes. Yeah, so after very interesting presentation from Vince, we'll dive a bit more technical stuff, and I would like to share my experience regarding microservices today. Shortly about me, I'm working as a software engineer in VMware and Tanzu labs. So basically our style of work, we make a very short engagement by the customers, very different customers from very different business domains, and try to help to teach the customer to modernize the applications. Normally it's legacy applications, or applications have some problems, some challenges. We have normally 4 or 6 weeks to understand the problem, find the way how to modernize it, and take a small slice and get it ready until production. This is my kind of daily work. Also quite active in the open source community in Spring and Apache projects, and sometimes I speak in the technical conferences. What is the plan for today? I would like to make a short introduction. What is the difference between monolith and microservice architecture? Should be highlight that there's no bad or good architecture style. Every of it has pros and cons. After that, we'll stick into the one use case I did 2 years ago for e-commerce online shop. This is very good case to demonstrate how monolith architecture iteratively split it and transmit it to the microservices. Also, we'll go through the pros of the monolith architecture. There's a lot of pros of that, and go in the way how to iteratively migrate or evolve the system to the microservice world, and to go through the challenges of the microservice and highlight the solutions for these challenges. Make some conclusions and lessons learned and recommendations. So first of all, what is the difference of the monolith and microservice architecture style? From my point of view, there are some aspects. This aspect is the most important. The first is system design. So monolith system is designed from scratch as a single large complex system. Yeah. Microservice is designed as a set of independent subsystems, let's say more or less independent. Of course, there are some relations between them, but the goal is to keep these relations as less as possible and as weak as possible. So it's more or less loosely coupled. Codebase. So normally for the monolith we have a single repository, monorepo, and for the microservice we have repository per subsystem. It's a bit different in terminology, business subdomain and microservice. We'll go on that later on. So for the subsystem, here I mean really business boundary context. So for the business domain, we split based on the business logic and domain logic, not based on some technological or technical aspects, but really from the business side. And we try to find kind of the boundary context. What is the areas more independent from the other, but really from the business point of view. And after that, we design a microservice. It could be the case that we have more than one microservice per business boundary. We'll talk a bit later about that. Deployment. So in monolith system, we have no other chance as deploy the whole system. So either all or nothing. Microservices are independently deployable. Data store, normally also monolith system use a shared data store, whereas different components talking with that, and microservice world, where the data store is split, is independent, is also per boundary context. Communication in the monolith system is kind of local communication. And microservices, we have to communicate remotely, so either using REST, HTTP, or messaging, asynchronous communication. Technology in Monolith, we have to use single technology because it's normally deployed as a one process. And microservice, we have a choice. We must not, but we have a choice to use different technologies for different processes, different microservices. Okay, so let's go to the concrete example I did 2 years ago with my team. It was e-commerce domain, so the online shop, and setup was so the business domain was just typical functionality of e-commerce. So we need to implement backend and frontend functionality to manage users, able to show the products, add the product to the carts, go to the checkout, pay for that, organize fulfillment, delivery, and so on. This is the domain and use case. It was 4 teams, each team about 7 or 8 persons. Technology was initially use Java, deployed on OSGI container, use a Hibernate, PostgreSQL, Karaf as a container deployment, ActiveMQ for messaging, and Apache CXF as a REST implementation. And it was used as Scrum methodology. If we look into the architecture, in the middle, we have see as a backend that exposes some REST API for the external clients. Of course, the front end that provide a web interface for the users. There are some external consumers, special consumers also use this REST API, mobile applications. There's some storages, PostgreSQL later on we use also MongoDB, ActiveMQ for the messaging. SAP was used for financial and Buchhaltung. It has also connections to some external creditworthiness check system to check the customer, is it able to pay invoice or not, and online finance system payment providers to pay. If you look inside this backend, you see there are already some kind of services with a REST API, but the whole application was deployed in the single container. So it's all run in the single Java virtual machine in a single process. So we have already some splitting here with some user service, card service, article service. But the team decided we have some shared functionality between the service, let's put it into the domain. So if there's some functionality shared between service, it will come into the domain. And this one is also usual case, some common stuff, utilities, common business logic. Let's use it everywhere. Let's put in the located in the core domain, and it was quite big. Connection to the SAP messaging and database was done using connectors. This is the internal architecture of the monolith. What was the good with monolith? What is the good experience with that? First of all, I would say with monolith we can make a very fast first steps. So first achievement was really fast with the monolith. We should not care about distributed architecture, distributed system monitoring, just develop in the single repository, deploy it, and it works. Built-in deployment was quite simple. Yeah. We also have a single pipeline, where all the teams are using for the build. Communication between the system components, we also shouldn't care about some distributed stuff and remote communications, or it was just local Java interfaces. So there's some isolation, some splitting between the components, but it is done using the local Java stuff. Easy monitoring, so it's just single process, single Java virtual machine, it's monitored, it's quite easy. Teams have also single is the same deployment, development and deployment rules. So they could be not optimal, but at least it's the same for all teams. And administration for DevOps perspective, it was also easy because it's homogeneous. It's just one process, one kind of storage. It's from DevOps perspective, it's easy. Yeah. So this is really was pros to use to start with a monolith architecture. And I normally also, by a customer, I recommend to start not to start with the microservices, start with monolith. I'll discuss the reasons afterwards. But from other side, especially when the teams are growing and system are growing, we're faced with some problems, with some issues. The first one, what I observe, that the upgrade to the new version of Java, versions Hibernate becomes more and more difficult. So, for example, migration to Java 8 takes about half year, so 6 months until all components will be migrated. The reason of that is we should migrate the all applications. They have no other chance. So all the teams should migrate the all components. Yeah, so in the separate branch, should be tested for the long time. We need to keep a parallel version of the whole system. It's quite long, quite difficult process. Second one, resilience. Yeah, so our container use the same thread pool and database connection pool for all components, for all services. And for example, if we have a high load on the product service and the thread pool is hosted, then we have also a problem with the user service, login with the card service. So basically, the whole system stacks. Shared deployment. Yeah, it's easy. A lot of cases when the one team not care about their part and make a deployment. Deployment is read, and all other teams should wait until the deployment is repaired, because all the stuff, all the components are deployed in the single container. Development cycle. Yeah, development cycle becomes longer and longer. So the time until you commit, make changes, and you can test this change grows. Because also locally, you have more complex system, complex deployment. Especially if something doesn't work, you need a lot of time to find out what exactly the problem is. Innovations. Yeah, so try something new and adapt something new becomes also bit difficult with the system, because you should care about other teams, interconnection, other components. Not all products is adapted and working in the OSGI container, so it becomes a bit problematic to try some new things. Scalability. I said already, some services in the e-commerce have a different load. For example, product service have very high load, and user service not so high. So users not so often log in as a search for the products. But we cannot scale it separately. We either have a chance to scale the whole system, the whole monolith, or nothing. Therefore, a lot of resources is unused, so the scalability is really limited in this case. And learning curves, if the new persons come into the team, I see that there's more and more time to understand the whole system, how the system works, how the deployment works, and start is really slow down. So sometimes people need 2-3 weeks or 4 weeks just to make a first commit and try something. This is just my observation. The decision was, yes, we perhaps need to split the system is too large. There are a lot of people working on the same stuff, and we need to somehow to split it. We go to our managers and say, yeah, it's not very nice situation, so time to business is very, very large. We need more and more time to develop new features. We need to split it. And we need perhaps, I don't know, 6 months time to redesign the whole system. Management says there's no chance. Yeah, we have a plan for new features. Our customers waiting for that. Sorry, but we cannot stop development for the 6 months. What is the solution of that? We propose kind of iterative approach. I also recommend for all customers to do it iteratively, not to try split and redesign, re-architect the whole system in one time as a big bang. Try to identify the parts and split it, make it working in production, deactivate in the old system, then find another part. So really do it iteratively, and after each iteration, the system should be deployed into production and working. So it's not only kind of experiments, but it's really production works. And the first step, I say step 0, what is very important, to abstract the consumers from the container. So consumers will talk not directly to the REST API of the container, but we put a component with a gateway, with name gateway, that have a control, they have a flexibility to redirect a request either to the old monolith system or to the new microservices. Sometimes we also do canary releases, not for all parts. That's some part of the traffic still goes to the old monolith services, most of the traffic. But we try, for example, 10% traffic for the new, already new world, and see if it works stable, it is OK. We redirect more and more traffic, and then switch the 100% traffic on the new system. This is a step very important to abstract consumer from the details of your API and have a flexibility to redirect the requests. Step 1, I also often recommend the customer what is a good start. Yeah, what is a good start to split a big system? I recommend to find the easiest service that have less as possible dependencies on the others, and go the easy way first. So take the easiest one. In our case, it was address microservice. It was quite isolated. It was simple one, and extracted. So it improves the motivation of the team if we have a first achievements already, and also the team trains how it works. And all the technical aspects of the microservice, like monitoring, tracing, deployment, is also tested on these simple components. I always recommend to start with the simplest one. So in our case, it was microservice. We split it quite easier. Like I think we need about 2 or 3 weeks to get it to make it into the production. The next step was a bit more complicated, and decision was made because scalability. So I said the price and availability microservices have very high load. So almost every request for the card or for the product detail page requires to display to show product details and prices and availability of products, of course. Therefore, load of this service is not comparable with load, for example, with a user service. Therefore, we need to scale it independently, and this was the reason why we extracted. So the price and availability microservice was extracted. It was also not a very complicated stuff, yeah, but this already we have some achievements that we can scale it. So you can we can arrange more than 3 instances of this, arrange 5 or 10 instances to make it also flexible, depends on the load. So the middle day or in Christmas time, it's more instances as another time. The next step was more complicated. So I show the architecture. They have these domains. And domains was a huge problem because they share it between the different services. So the teams, different teams, works in the same Codebase. It already was quite painful. How to deal with that? I decided that time for very easy solution. Perhaps I also recommend for a lot of customers to go this way. We just make a copy of the domain the first time. So every domain becomes a copy specific for this service. And we have a clean split of the code. Of course, we have some duplication, yes. So the dry principle, don't repeat yourself, is violated, definitely. And for some bug fixes and features, we need to do it in the 2 or even 3 places. But the gain from that was the more important as drawbacks. So the teams, every team has their own codebase, they own the code, and have the full flexibility to improve it iteratively. So they delete the stuff that they don't need. Redesign, of course, it takes a bit time, but they can work independently, have their own plan, and they really own the code. They also increase motivation of the teams. Also, a huge problem was the core domain. This the stuff, common components, that the all common functionality living on. For this, I decided to split, recognize business related stuff and business related functionality common into the also services domains, will be joined to the service domains, and some technical functionality that's shared for the all projects was put in the kind of third-party library. So you have, it still has its own repository, has its own release lifecycle, and we just use it as a third-party dependency in the services. So this way, but it's only technical stuff, not any business-related functionality is there. Yeah, so after that, we reach this state that the servers are independently deployable. For deployment platform, we use a Google Cloud with a Docker and Kubernetes. But it's not cleanly independent because it still uses the same storage. So for example, user service, card service still have a user table with a foreign key to the card, and service user joins to get this information. Therefore, they're not completely independent. If the card team changes something into the schema, into the data entity, user team should also adapt their own code. So it's also still possible to break it. Or if some table has a forgotten index or log, then the other service immediately fill it. So it has influences still interdependency between the services in sense of storage. And I would say, yes, it's unfortunately, it's the most complicated part. So split the code is not so difficult, split the components. You can copy, in the worst case, you just copy it and live with duplication. But split the data, it's the most challenging part of the splitting microservices from my experience. We use two different approaches to resolve it. First, is related to user service. They just instead go indirectly to the database, to the user tables. It uses a REST interface of the user service to get this information. So if you need some information about user, just call user service using REST API. Yes, it's a bit, in performance sense, it's a bit longer. But as far as we have horizontal scalability, a good network, so the performance impact is not so bad. But the gains is, of course, so independent deployment and independent scalability. That brings a lot in this case. Another solution, it's a bit different. Between cart and checkout service, we use a different approach. In this case, have kind of replication, asynchronous replication between the services. So the card service has own table, card tables in their own database, and checkout service has basically a copy, so replicated copy of the card information. And if something changed in the card, we just publish a message. Checkout service listen for this message and make appropriate updates in the card information in their own database. So in this case, the database is independent, and they are synchronized using the messaging mechanism or asynchronous mechanism. So after that, we reach the state when the services are independent. They use independent data storage. The teams could deploy they are separately independent one another. And the time to production, the feature development, they really improved essentially. So instead implementing feature 2 weeks, we need sometimes 1 day or 2 days to bring them in production. So the management really sees the goals of that. But the microservice is not a free lunch, and we faced for some challenges, and we need to solution for some for these challenges. So I split it to the two groups. The first is technical-oriented challenges. Okay, the first one is quite easy. We definitely need the CI/CD. There are no chance. With Monolith, basically you can do some steps manually or investigate something manually. For microservice, no chance. So we have more than 10 microservices. To do something manually is absolutely no-go. Monitoring solution. Yeah. Also, sometimes for Monolith applications, possible to start monitoring tool, see what happens in the production. For microservices, a lot of number of processes, virtual machines, so we need some kind of central monitoring stuff which we see the health status of all systems. It's absolutely necessary. Logging is the same. For microservices, it becomes more complicated because in the monolith, have basically one place where all logs are. You can just look at, grab something for error. Microservices, you have about 15 or even more if there's a lot of instances created machines, and every machine has their own logs. And looking something into the distributed logs is not possible at all. And it's absolutely necessary, in my point of view, to have a central place we can search for the all logs. So that's the problem. It's really helpful. We need solution for that. Message tracing. Also, Microservice, what is important to understand where the problem happens. If exception happens, in which components it was. If you have a slowdown, to understand who is responsible for that, especially in chain calls. Is one service called another service. So we need to understand where the message is. So for that, tracing, so traceability and debugging possibility is absolutely necessary. There are also some organizational challenges. Features requires changes in the multiple services. Sometimes it happens in the business that we need to, make it feature to go with feature into production, we need to changes in the some microservices, how to manage it. Wrong splitting and the team responsibilities. Yeah, sometimes we make a mistake by splitting the components, the microservices, and they are quite expensive, I would say. Release cycles and central quality assurance was also becomes more difficult because in the monolith world, we have a clean lifecycle scheduler, and after each period of time, or after each phase, QA validates the system, verifies, and say, yes, we can go to the production. In microservices, every team is responsible to deployment, and deployment, so release cycles are not synchronized, so every team decided when it's deployed, and central QI was not so easy. Yeah, it's still possible, but definitely more difficult as a monolith world. Sometimes it's also difficult to recognize, is it feature already in production or not? So is it all teams, all domains are implemented already, and we can enable it for user, or not, because the teams deploy independently. Okay, what about the solution for that? For technical CI/CD, yeah, we use Jenkins for that. This remote application was packed into the Docker container, and using the Jenkins deployed into Kubernetes cluster in the Google Cloud platform using Helm charts. Yeah, so the build was completely automated. Even later on, for some services, make based on commit. The whole integration, when the whole integration and system tests are green, the components will be automatically deployed into production. So for some service, it's not for all services, but for some services we have such kind of state. Monitoring. We use some commercial product named Instana for that. So VMWare also provide some product to monitor the stuff. I just say that's quite important to have such a tool and monitor not only system resources like CPU, memory, state, number of threads, but also would be nice to monitor the durability of calls, how long the calls takes, how long the database communication takes, and so on. So that kind of parameters. Sometimes also business parameters, how much requests per second we are processing, and what kind of request is coming on is absolutely necessary. So I was quite happy with Instana. I would get a huge job, good job. But as a commercial product, you need to buy the license. For login solution, what we did, every service produces own log, written in the system out. And we use a flying bit parser to prepare this kind of logs and put it in the central Elasticsearch log server. So you can really, single central place, you can search all the logs that produce the system. For the tracing solution, we use Spring Boot Sloys based on Zipkin Brave, and idea that every message becomes an ID, and you can monitor the round trip of the message, and you can really recognize which component message is coming in, coming out, how many times it takes to process the message in the single component. So the round trip and message was monitored. I really recommend to look on that. It's open source. Sloys is a component of Spring Boot that based on the Zipkin Brave open source project. What we do with organizational challenges. Features span multiple services. Most important was if they make some changes in APIs, so external APIs what use another component, do it in the compatible way. For example, if we need to rename some attributes, we just first add the new one, wait until all the system is migrated, only afterwards deleted the old one. So the change should be compatible. In this case, you still can deploy independently. So if you deploy the new version, all components, other microservices not broken. Communication between the team is still necessary. Yeah, so if you develop the feature that goes through the many microservices, it's still possible, still necessary to have some communication and common solution. But I would say if it's too much such situations, if you see that every feature requires changes in more than one microservices, perhaps something wrong with your splitting. You should rethink either your boundary context is still correct. Perhaps go a step back and refactor, redesign the responsibility of the microservices. Splitting seamless responsibility. So it's exactly the point. Mistakes in the splitting of the microservice is expensive because it also requires some organizational change. If you split microservices in the wrong way, you split the teams in the wrong way, and to fix it, it's quite expensive. So you need to reorganize the teams, reorganize the repositories, pipelines. Therefore, it's also the reason why I recommend to start with Monolith. In Monolith, you can take the experience sometimes and really see where's your boundaries, where's the boundary context, where's the stuff functionality that fit it to the microservices. But of course, system evolves, and with the time, you need to refactor, rethink your responsibility, especially the signs, really, if the feature requires changes in 1, 2, 3 microservices, perhaps something wrong, and you need to compose it together or split it, split in more smaller part, or merge the services together. Release cycles, the central QA, here it just, the teams should really take responsibility on that. Still from the development, from the implementation feature to deployment, and also care about production bugs and if something happens production. DevOps, central DevOps is still there, but they just provide the rules and help the team to resolve common problems, but they not take responsibility for every production error, production problem. Conclusions. So the most important is no silver bullet architecture. They're not solution for all problems. So for some situations, some cases, Monolith is the right choice for some microservices. Especially for the start, for the greenfield, I always recommend to start with Monolith. You have a fast progress, you understand your business domain better, and you make the splitting later on with high quality. Yeah, starting with Monolith is faster. Also, splitting Monolith to microservices not only because it's cool. Yeah, microservice architecture is cool. Yeah, and we produce 20 microservices and nano-services. But you really need to have a good reason for that. I mentioned this. This could be scalability, could be responsibility between the different teams and business domains. It could be performance and resilience, that you could abstract communications with some external team from the external components, external systems from the rest of the system. But you really should have a good reason to extract the microservice from the model. So it's really not prefer, I would say it's must to do it iteratively, not try to do it from scratch as a big bang for the whole system. Start with one simple server microservices, try it, then decide to do it to the next one, and after some iteration, the whole system will be migrated. Yeah, starting splitting with this more simple and less dependence services to have a good experience set, and after that decide for the next candidate. And of course, so be aware about the technical and organizational changes after the split, and care about solutions for that, like CI/CD, central logging, tracing messages, monitoring, asynchronous communication that you will need for the microservice architecture. Also, the mistakes in the boundaries are quite expensive. Here, we really need to think more than one. And already in the monolith, you can recognize, you can also design. It's a bit independently already to isolate decoupled using Java interfaces first. Yeah. And after that, the Java interfaces will be based on the external API for the microservices. And you can test a bit in monolith stuff, and only after that extract it. Yeah, so basically it's all from my side, from my experience with this project and some other projects. Do you have any questions?
Hi, I'm Dobry from SAP. I wanted to ask about your opinion related to the feature flagging services, like services that can help you to bring some consistency in the releases when you roll out the new features that are deployed in several microservices or require the changes in several microservices. Do you explore such solutions? Do you try out of them? What is your opinion? Do they
so when the changes really influence and have into the more than one microservices, you mean? Yeah?
Yes, and do you use such feature flagging techniques like feature tolling, central service for the feature flags, and so on?
Yeah, so the first one, I really a big fan when the new feature or fix happens only in single service or single boundary context. So boundary context could have also some microservices technically. The typical example of that, if you have some service, it's exposed functionality, and we have some batch process, for example, that one per day scans something and import the external information. They works with the same data, and they belong to the same boundary context. and there is the single team responsible for that. And I'm a big fan to that have every feature is limited to the one boundary context. It's not goes through the all or more than one boundary context. In this case, it's quite simple. So the team, only one team responsible for that. And normally 80–90% of features should be in the single boundary context. Yeah. But of course, yes, it's real life. We have some exceptions of the rules. And there are some features that need to be done in more than one boundary context and deployed more or less synchronously. In this case, yes, most important is to not to break the changes. If one team is faster as another, they implement the change, make the compatible API first, that not to break the other components. Also, feature toggles I use for that, so you can deactivate features on the first time, and then after all other team are ready and deployed, activate the feature toggle. Yeah. And of course, communication with the team is important. But I would say if you see the 30 features takes more than 80%, then perhaps something wrong with your splitting into the microservice or boundary context. Yeah. You need to rethink it to minimize the features that go across more multiple services.